Put up on this now. Welcome to a video.
I've joined, but here we are. Request.
Okay. Cool.
We'll see what that delay is like.
Yeah, we'll see. It doesn't really matter.
No, not up there.
Okay. Ready to roll?
Yeah, man.
Okay, so hello everyone, both on Instagram and YouTube. We've got two things going on. Thank you for you've joining us on another episode of Wine and Viticulture Education. My name is Gus Black, and I'm a London-based wine bar founder, your professional taster, and now importer of wine.
And I am Dr. Dylan Grigg. I'm an Australian viticulturalist, and you may know me by my Insta handle, G Dilla.
We've started this little channel to share kind of our passion, and our objective in this series is to bridge the world of wine consumption with its roots in growing grapes. The topics will be wide-ranging and mostly nerdy, as there's no set script, and you, the audience, are encouraged to ask as many questions as you need, mostly from Dylan, because he is an actual PhD, while I'm just an idiot. And also to throw some opinions into the mix as we tease out and chew the fat on some trendy and not so trendy subjects. As a disclaimer, this is not a scientific kind of talk, but it's instead an insight into what a sommelier and a viticulturist would and should talk about over a beer. And the big subject today is pest and disease, the real truth about spraying. So big question, why do we need to spray?
Well, I guess first it's good to define what we mean by spraying. So there's all sorts of spraying you could do in viticulture, but we're referring specifically today to applying a solution to the foliage of the vines to prevent any undesirable pathogens, protecting the leaf and the fruit.
So what are like the main targets of those sprays?
So I guess in viticulture, we're talking about the main targets being the big three: powdery mildew, downy mildew, and then botrytis. So these are global issues and things that that need treatment basically anywhere grapes are grown. So there's so many ways that you can apply a spray. You can use, hey, check out this. You can use, of course, zoop,
a tractor.
Hey,
who doesn't love a tractor?
Who doesn't love a tractor or a bad picture of a tractor on Instagram? So you can have a single row spray unit. You can have a twin row spray unit. You can apply some sprays, you can apply dry, but usually it's a spray solution. So you dissolve whatever you're putting out in water and you try to most effectively cover the foliage of the vine by displacing the air within it to get good cover.
Oh, cool. So should we discuss kind of like what kind of sprays you would normally spray?
Oh yeah, that's a good place to start. So if we break down the three big ones, so if we go say powdery mildew. Now, powdery mildew is a disease. I know that in this series we're talking to people that are both in the industry and outside the industry, or people that maybe don't have very much contact with plants. So powdery mildew grows on the leaves and can grow on the fruit and the flowers, and it causes off taints in wine. And if it's bad enough, you can even get, it can have an influence on photosynthesis. So it makes the vines sick, basically.
Yeah.
So as the vines start growing in the start of spring, there's these spores are everywhere. The chance of a spore landing on the shoot is pretty low, but as the shoots get bigger, the chance of spores landing on gets greater. So we need to improve our spray coverage, but also I might make a few COVID-19 references. But once you have a spore land on and that spore starts to reproduce and create more spores, you get the exponential growth. So action early is the key.
Wait, so how do actually spores normally like get there, or what environment do they normally kind of like propagate most?
So I guess this one branches off into a little bit of canopy management. So the spores for powdery mildew and downy mildew like different types of climatic conditions. So we call powdery mildew the fair weather disease because it likes fair weather. If it's too cold, it doesn't reproduce so quick. If it's too hot, that can also stall its development. Or if it's too wet, it can actually, the spores take on a whole lot of water and they can't deal with it, so they actually explode.
Oh, interesting.
So in some scientific trials where they're testing, maybe they're testing sulfurs or different chemicals, the control that is just water can still have some efficacy. So
interesting.
When all else fails, spray with water. No.
Which is really interesting. Well, because, and like from like a layman side of things, is also that water was the major issue when it comes to powdery and downy mildew.
Well, that's what people think. I mean, powdery mildew being the fair weather disease, it needs some free moisture, but it might only need 1-2 millimeters. It might be the dew in the morning that's enough for those the resting bodies to crack and to distribute more spores. Whereas if we go to the other key pathogen, which is downy mildew, now that's your wet weather disease. That's the one when it rains and it's humid, it's like, it does the whole exponential growth really quick. So the downy mildew is the one that's controlled with copper.
Okay. Like in copper as a spray is quite an old kind of like treatment.
Yeah, absolutely. I mean, before 1850 or back in the early 1800s, I guess everything was organic because they didn't, or in Europe anyway, didn't need to spray. It goes back to previous episodes when the globe got smaller and there was this this transfer of plant material both to the Americas and to Europe, back and forth. Does copper kill earthworms? They certainly don't like it. That's why it's a heavy metal and it's highly restricted, which hopefully we'll get to. Sorry, if you're on the YouTube, we're answering questions on Insta Live as we go. So you might need to get me back to where I was at with copper. So 1850s, no powdery downy. Powdery and downy came over to Europe and was a massive drama. So they needed to figure out how to control it, and they discovered that a Bordeaux mixture, which is like copper sulfate and lime, controlled the downy, and the sulfur controlled powdery.
Okay, so they would just use a combination of both.
Yeah, and paint them blue. Paint them blue. It's a blue solution.
Okay.
So early control. I mean, in Europe they got over the introduction of these mildews, and then we're like, okay, we can kick back. We've got our Bordeaux mix. Let's get back to growing grapes and making wine. And then it was like, hang on, what's this growing on the roots? And then it came to phylloxera.
Yeah, wow, double whammy. Also, like Amber did ask, how quickly does powdery mildew develop / propagate, and where does it come from?
Oh, Amber's got the best questions. So powdery mildew overwinters. So if you've got it in your vineyard, depending on the disease load at the end of the season, so in autumn, the disease sets up resting bodies, and these resting bodies will overwinter. And then when it comes to spring, welcome Aaron, when it comes to spring the next year, and things start to warm up and there's some free moisture, these resting bodies pop open and the powdery looks for a new host, which it's an obligate parasite, so it grows just for grapevines, just on grapevines, I should say. And once it's on the vine, that's when it's got its perfect home. And if it has good environmental conditions, be they caused by weather or poor canopy management, like a canopy that's big, well, I'm doing it small because it's spring, but in the summer it would be big.
Yeah.
A canopy that doesn't get a lot of light, doesn't get a lot of wind, and these conditions can help the powdery mildew grow. So in the real world, 7 to 10 days you can get a new generation. So this exponential curve in the lab under perfect conditions, like 24 hours at the same temperature, which I think I've experienced in some summers, you can have a new generation in 5 days.
Oh, wow.
Yeah.
It's quite quick.
So it's quite quick. So if you're not onto it, it's the same as the COVID-19. It's you need to attack it early, because all you're doing is trying to keep your infection under control. You can't eradicate it totally unless you have a nuclear spray program, but we're not going to go there. So I think that answers your question broadly, Amber.
Also, and then I actually had like another question, which was, after people prune, they burn the wood, and I was told it's to get rid of diseases. Is it these two mildews, and do they nest in trunks? Question mark.
They do overwinter or nest in the old wood, which is why it's also important when you prune and all your prunings fall on the ground. If you had an infection, those resting bodies will be on the wood. You've pruned, they're on the ground. They're sitting there waiting for a rain splash or the right conditions the next year to get back on the canopy. So vineyard hygiene is one method to reduce your sprays. So burning, yes, is one way. I don't think it's that great, but it will reduce your overwintering inoculum, but the same as the COVID-19 is you only need one person to come on a plane. You only need one spore. And if you're not watching, you got your 1 goes to 2, goes to 4, goes to and you're exponential again. So burning the wood, if you want to prune with smoke in your eyes, go for it. But there's other ways. And I think there's better ways to use that wood in the ground.
So then, like, we could kind of like go on to, is it possible to just not spray at all?
It all depends on your level of risk you're happy to accept. So of course you can not spray.
What's the worst case scenario? What's the worst case scenario? What's the worst case scenario if you did not spray anything in your vineyard?
I guess a general disclaimer is to say that everywhere around the world that we grow grapes have very different environmental pressures.
Yeah.
Right? Some places can get away with 2, 3, 4 sprays or none in a year. Some people can must spray 10, 12, 14 times in a year. So if you're in a really humid environment and you don't spray, it's game over. So by the time your shoots are 100 millimeters long, you'll have disease load in there. Then that will increase exponentially along with the vine as it grows. And those flowers, when the vines shoot, they've got the little inflorescence that come out, the flower clusters. Now they're really highly susceptible. And just at the point where those flower clusters are expanding and about to go through flowering, they're super susceptible, because when the flower caps drop off, it creates a little scar. So you've got a vineyard full of susceptible tissues and scar tissue, which is like an open door to a pathogen.
So it could kill the whole vine, like in practice.
What I'm getting at is you'll have disease on your flowers, and if you get just the right conditions, because powdery mildew builds over time with fair weather conditions, whereas downy mildew needs like we used to call it a 10-10-24. 10 millimeters of rain, minimum of 10 degrees with 24 hours period with leaf wetness. Once you get that, you get a primary, then you get another specific set of conditions for a secondary.
Yeah.
You get that in this vineyard that's not sprayed. Those flowers will get infected straight away because they're just so susceptible.
And then some, and there's other questions saying that some people spray milk solution. Does it work from your experience?
Okay, so some people spray milk because this is to control powdery mildew, so oidium, and milk has, well, when you spray it in the protein, when sunlight hits it, the way it breaks down, it creates free radicals, which can pierce the fungal hyphae, and yes, it works. You can spray milk like out of the jug, or it's perhaps better to go to your local biscuit manufacturer or dairy, and you can actually get whey protein, like the stuff in your fridge, Gus.
Oh yeah, you know me and you. Obviously, we are the two most muscular men in the world.
Exactly.
So okay. So should we kind of go through?
Can we go back to if you don't spray? Because
yes, I think so.
No, you need to crack the whip. So if you don't spray and it's a wet area and a warm area, you'll get powdery mildew and you'll get downy mildew. You'll lose all your leaves, you'll lose all the crop, and you'll be very lucky to harvest anything.
Okay, so you basically would not get fruit, but would this?
No.
So would the vine actually survive though, like during those diseases?
Grapevines have indeterminate growth. So there's nothing that stops that shoot elongating. So you'll often see it where you get a lot of disease, the leaves can fall off, but the vine will keep pushing if you have the water and the nutrients.
Okay.
So if we're talking about not spraying, where you would normally apply 12, 14 sprays, it's wet. So you've got water and you've probably got nutrients. So they'll keep pushing on, but they will get more tired over time. If we put it back to, some of you might have seen an Insta post I did a while ago of a client and mate who has no spray vineyards. It's possible in some parts of the world because it's hot and dry and there is less disease pressure. So it goes back. Can you not spray? Sure, but it depends on your level of risk you're happy to accept. If you're happy to lose 2 years in 5, 3 years in 7, 5 years in 10, potentially, it's a risk. But in some areas where it's hot and dry and you haven't had a history of disease, you don't have the inoculum overwintering, and you've got good canopy management to avoid the need to spray, it can be done.
Okay. Also, and there's actually been some quite great questions coming out, which are like, could you explain the concentration factors of copper and sulfur when spraying?
Wow. Okay. That's come from Australia, I think.
Well, it is someone who's extremely experienced now, and also he's gone out to Japan and done some sake brewing and stuff. So he's actually got quite really he's got a lot of experience. He's French, but he's spends time in Australia. Okay.
Briefly, so if I put this, let's frame this in the Australian context. I took this particular theory over to Europe, and we've used it. We're using that at in Catalonia. But
hello, Anna. She's watching.
She is. Bon dia. So in terms of mixing your sprays, it's easy to say I'm going to put 2 kilograms per hectare on my vineyard of copper or of sulfur, for example. All right. So that's great. But you, Gus, have got your vines planted super close together and you've got 10,000 vines a hectare. My vines are planted 3 meters by 3 meters and I've got far less vines per hectare. Do we both put 2 kilos per hectare on? No, but that's an old method that is still in use on how to calculate the dosage. Okay, so what you end up doing is, if we go back to a standardized vineyard of like 3 by 2, whatever, if you apply the spray rate at the start of the season and you use the same rate through, you're generally overdosing massively at the start as the vines are small. And then are you spraying the same? Your dosage relative to the canopy is decreasing. So when you get to full canopy, you're underdosing.
Okay, so
enter concentration factors. This is for the practitioners out there. Sorry if you're just into plants or more into wine, but basically you use a concentration factor if you're not wetting the canopy to the point of runoff. Point of runoff being maybe 1,000 litres. So if you're applying 300 litres, you need to find the difference between 1,000 and 300, and you need to concentrate your spray up to make sure you're getting an effective dose. It is the most important point when it comes to spraying. Irrespective of the biology, the technology, what our target is, if your machine's not calibrated with good jets, forget it.
What's pointless?
It's pointless.
It's inconsistent. Doesn't work.
It's totally inconsistent, and it's a waste of time. And you might get by because there's a massive fudge factor with sprays. So people that have a philosophy of reducing inputs or working more with nature will look really closely at the vine growth and the pressures, and they'll pull back on inputs and see a little bit of disease. Because if you can see some disease, hey, it means you're close to the edge. But if you're out there and it's nuclear and you don't see anything, then maybe if you want to, you can button back a bit.
Okay. Also, we've got like another question, which is what which we discussed earlier that you didn't want me to ask too many questions about. But what's your experience with dynamization of a lot of these more natural sprays? And I was told that it changes the charges of the solutions, making them more effective.
Yeah, no, that was yeah. Thanks, Gus. No, it was just getting into. Actually, I'll tie this in with Al de Kaiser, the number one independent distributor in Tasmania.
He is number one. Big Al. Big love,
fine
big Al.
wines. He asked about prebiotic and probiotic sprays. So prebiotics being a plant stimulant that boosts the activity of beneficials or beneficial insects, which can be antagonists, and probiotics, which are more challenging, which this question kind of brushes on, which are live microorganisms. So live microorganisms that offer a health benefit to the host. So using this, I mean, dynamizing is mixing. So you're adding oxygen, so you're adding air to it. I don't know specifically about changing the charge of the solution, but if you're working with a probiotic, then you're creating an environment that is going to foster the development and the growth of the beneficial microorganism that you're going to spray.
Okay. So it does have benefits.
I don't know about dynamizing a tank full of copper and sulfur.
Yeah. Okay.
But if you're applying a biological or a live bacteria or a live fungal spray like trichoderma, then yes, it would be of benefit. Not sure about the charge. That's probably a good question to research.
Also, sorry,
trichoderma is a fungi which has been shown to what does it do? It stimulates the plant's natural defense. It puts the plant on a state of alert.
Oh wow, that's pretty cool.
It's cool. We need to get a deeper understanding of plants microbe interactions, because it's got to be the future of getting away from copper, for one, spraying a pollutant and a heavy metal.
Because there's been quite a few questions now that have just come up about copper. One from Dave Fletcher saying, what are the alternatives to copper in organic vineyards?
Dave, welcome. Well, the truth is right now there are none. I've read research papers which have tested 100, there was one paper that had well over 100 plant-based alternatives. There's some glimmers of hope amongst that, but at the moment, copper's the only thing that we've got which can stop the sporulation, the spread of the oomycete, which is downy mildew. Because, you know, we talk about fungal management, but only a few years ago it was reclassified to be algae. Hence why copper works. So Fletch, to answer your question, there are some plant-based tonics or sprays which have efficacy, and they have been shown to work quite well until you get a season with high pressure. You can read a number of these reports and investigations into plant-based or alternatives for downy, but there'll be 3 years in the study. They'll have 2 good years, and the 3rd year will be wet and rainy, and boom, the only thing that stands up is copper. So we need to find an alternative.
Yeah.
I know, what is it in Europe now? Like 4 kilos a year, down from 6, down from 8. So you can only apply 28 kilograms of copper over a 7-year window. So they allow you to overdose in some years.
Yeah.
But go too hard, you need to come down for the next year.
And then we actually kind of touched on it like earlier, but someone else asked, how damaging is copper residues in soil from conventional / organic sprays?
First point I'll make is that copper is, it's elemental. It comes from a rock, like sulfur, even though we don't get our sulfur from a rock anymore. But copper's elemental, so it's an allowed input in organics. It's also an allowed input in conventional. So how damaging is it? I'm going to tie in another question that I got earlier today here, if I remember. So don't let me get too far off track, Gus. Copper's very damaging. It's a heavy metal. I do many soil tests every year, and you show me a soil test of a vineyard, you can judge the age by the level of copper in the soil. It stays in the soil.
Wow.
So it's a controlled heavy metal, which is why the EU, well, most governments, but the EU especially, want to phase it out. And if they phase copper out, organic viticulture is in big trouble. In conventional viticulture, people will use some copper, but copper's like sunscreen. It's only got it's got contact activity, unless you talk about some of the new glycosylated coppers, but that's another discussion. So copper's like sunscreen. It sits on until it's washed off. Conventional viticulture, you've got the option of systemic and translaminar products. So in an organic vineyard, you need to go out and you need to spray copper before it rains. And if it rains, you need to spray it again. So you're spraying frequently.
Yeah.
So there's more copper in your soil getting washed off and coming down with the leaves. Conventional, you might spray copper as a contact, but you might spray a systemic, which goes into the plant and fights the disease from the inside out and buys you 10, 14, 21 days of cover.
Okay.
So you haven't applied copper for all of those sprays leading up to that point. So your total copper usage in conventional is less harmful, but it's offset by using synthetic methods of pathogen control. So I think that's the short answer, if there is one from me.
Yeah. And then what about this question that you received earlier today?
Which one? Oh,
yeah.
Say? Who was that? What was your question about copper? No, I tied it in. One Sun Booze.
Okay. Okay, fine.
What's kind of the trade-off between applying copper or applying only surface sprays frequently all the time, or applying a systemic and taking a break? Which is the lesser of two evils, was the question, which I think I answered there.
Also, and someone was just asking about like, is seaweed or and is it like a seaweed based spray that could be used as an alternative to copper, or do you have any experience of like seaweed products?
Love them. Yes, I do. I've been using seaweed products for for a long time, since like the mid 2000s or something like that. They are classed as a prebiotic.
Okay.
Some are mixed as a probiotic. They've got, and they're often mixed with humic and fulvic acids and things like that. But seaweed, yes, it has plant strengthening properties. So I always use seaweed in minimum first 4 sprays, like as soon as you go out the blocks with your short shoots, 10 centimeters or less. Use seaweed every time because it strengthens the plants and it can reduce the stress associated with, temperature and pest and disease to help to fight or become more resistant to diseases.
And then what about it as like instead of copper, it's not a trade-off? Like it doesn't help with.
No way. No. It's not a trade-off. You can use it, like I said, if you go back to super hot and dry years in a place like, one I know well is the Barossa Valley, you can get away without spraying anything, or you can just go out with, your plant tonic, which is great to do, which is like your fish, seaweed, organic based, we call them stimulants, but that's just nutrition.
Yeah.
So it helps, and it definitely is good to have in the tank when you're going out, but no way to go out without copper. You'll learn the hard way.
And then is there some argument for synthetic sprays?
I think the argument is one I've touched on twice. And I've touched on twice. If people do, I don't have any at hand, but life cycle kind of analysis or a total carbon footprint of organic versus synthetic, you'll see big differences. Organic viticulture, you need to be out in the tractor because, like I said, it's like sunscreen. They're all contact sprays, which is why we use a lot of natural products to try and boost the plant's defense and to try and act as an antagonist for these key pathogens to try and stretch out time we need to go back. But conventional can, if you choose the products, can spray systemic. It's in the plant, and then you get a bigger window. So there's less diesel being burnt. There's less compaction. There's less heavy metals going into the environment. But what is going into the environment are synthetic chemicals. Yeah. Some are based on plant or fungal or bacterial origins, but replicated in a lab, and others, God knows, scientists cook them up.
Also, sorry, go on.
I was just going to say, it all really depends on your philosophy and the philosophy of the viticulturalist, vineyard manager, winemaker, and the property. And that's the key thing why people will go, no, it's organic all the way and I'm prepared to take a risk. Or you'll say, I'm not spraying a thing and I'll wear that. Or I'm not risking a single berry and I can within the bounds of the law. And there's safeguards, things called MRLs, maximum residue limits, and very strict guidelines on when and how much of these synthetic products and the organic ones you can spray. So they count from the harvest day back. Some you can't spray after flowering.
Okay, wow.
100+ days to give it plenty of time to biodegrade, photodegrade, and not be found in the fruit.
And also then you actually touched on it briefly, but it's kind of worth you come back to for like another question just to round it out. But which is more to do with that soil compaction, like from use of tractors and stuff. So how do you mitigate that if you're having to, like, if you're organic and you're having to spray like copper? How do you mitigate that?
If the tractor has to go out there, you really only want to go out there when the soil's in a condition to take traffic. So you don't want to go out when it's totally saturated because you're going to squash down in the soil. You're going to close all of the pores, all the air pores, squeeze out the water, and basically screw your soil really quick. So you want to be careful when you go on. And if your tractor's going out there, this goes to a whole nother conversation about floor management.
Yeah.
But you want to have...
Good subject, actually. It'd be a great subject.
Yeah, that would be actually. If you're spraying and you've got compaction, we get what's called a tram line. So where the tires roll, you'll get compaction. It'll go down like 300 millimeters. So if we had a red line through the soil, where those tractor tires go, you'd see the red line go like this.
Yeah.
Compaction. So it stops the roots going all the way to the mid-row. They'll turn around and go back, or they'll go down. So the best way to alleviate that is to have grass, have species, have something growing in that area where the compaction's going down to spread the load. And deep ripping, I mean, cultivation, maybe it's evil. There's another episode, but deep ripping can open that up, alleviate compaction, so long as then you grow something in that soil that's going to keep those pores open and keep that soil friable. But the number one is don't cultivate all the time. Don't over cultivate, and don't drive on it when it's wet if you can avoid it. Big footprint tires. There's quite a few. You could probably list 4 or 5 key things to reduce compaction. But a 3-ton tractor is going to put pressure on the soil.
Also, there was one kind of question from Jared on YouTube who was asking, like, in steep vineyards such as our own, where they spray with hand sprayers, how do they get doses right?
When sprays are tested for the market, they use a hand sprayer. So a hand sprayer applies a dilute concentration and gets practically perfect coverage. So they get good coverage because they're able to see it and spray everything. They're not in a tractor with 2,000, 3,000 litres behind them, like powering away with the wind blowing, 100 hectares to do, got to go out for lunch, you know. They get good coverage because they're on the ground. Yeah,
so they're actually more beneficial, actually doing it by hand. More control.
Well, there's a human element. I mean, you've got to be out there standing amongst the stuff. So you'd be more preferable to be working organic, but you know, you still don't want to be breathing in copper and sulfur and, you know, smelly fish guts and algae.
Also, like Fletch had a comment on your thoughts on GMO for disease and drought resistance, like genetically modified. Like Jimmy, comment on that.
GMO. I think this goes on to another episode that we'll probably do on hybrids. Yeah. Because breeding for resistance, I think Fletch using the acronym or using GMO just makes me go, oh, hang on, okay, we've got to be really clear about what is genetic modification and what is breeding for a desired outcome.
Yeah.
There's GMO plants in laboratories, there's GMO plants in the wild, and there's such a consumer kickback that they're shelved. And I think marker-assisted breeding, targeted breeding, will probably take a bigger place than getting a gene and sticking it in. Yeah. So marker-assisted is, instead of just mixing all the plants together and having like 20,000 seedlings and going, right, 20,000 seedlings, 2 years later, expose them to a pathogen and see which one lives. Oh, none. Yeah. Or one. We can get those 20,000 as soon as the first green tissue comes out. We take it, we sequence the genome, and we look for the genes of resistance that we know the locus, we know where they are. And if it's in any of them, you screen for it. It's in that one, that one, and that one. We keep them, throw the rest away. So instead of breeding taking 25 years, you can speed it up. But the genetic recombination, so disease-resistant varieties and Vitis vinifera, standard varieties coming together, that is the natural process. Gene editing, CRISPR-Cas9 style, Google that. That's another conversation altogether.
Yeah. Well, like we've
a long
kind
way
of
off, Fletch.
well, we've had a good old almost 40 minutes of this, so like we should probably just sum up. And
Sorry.
because like, and it is a big subject and it is a really interesting one, but kind of like to sum up from what I garnish from it, that like copper is in some ways relatively essential at the moment, especially for disease pressure years. But like the future is not copper because it is a heavy metal, and ideally we'll find a way out of it. Correct. But also that like hybrids and breeding might be a way forward. Is that the major take you take back from this, would you say, as a summary?
To avoid spraying, you want to no spray vineyard, then it's got to be a hybrid. But you still need to spray once or twice a year so that the pathogens don't work their way around the resistant genes. So we want multi-locus resistance, or else we get that Californian AXR1 phylloxera situation.
Okay.
Google it.
Well, anyway, so we'll probably have to call it here, but thank you so much for like coming with so many really, really great questions on a really contentious subject that is discussed and argued like all the world over. So like Dylan, thank you so much for your clarity from your background as well, most importantly.
No, well, I just like to say that, you know, controlling of pathogens is, no matter what they are, is key to maintaining plant health, longevity, and wine quality. And we need to find the most environmentally friendly and sustainable way to do that, which includes spraying for one, but canopy management and manipulation of the vine. So we need to spray less. It's a multi-pronged approach.
Basically, it's no simple answer, and there never really is in life, is there?
No. keeps me in work. That
it does. But thank you to everyone who joined us today. We'll see you next Monday this time, most likely with a special guest. But who could it be? But anyway, lovely to see you. I was Gus Gluck, and I still am.
And I'm still Dylan Grigg.
And we'll see you next Monday. Thanks a lot, everyone.
Thanks a lot. See you around.